In this video, hopefully I can convince you that Desmos is your cheat code for the SAT. Imagine you had a cheat code for the SAT that almost nobody is using correctly. What if I told you that with just a few Desmos hacks, you could solve problems in seconds that most students spend minutes on? Stick with me and I'll show you how to boost your math score into the top 1%, no extra studying required. So first of all, hello, my name is Lucas Blois and I'm here because I love to help students with the SAT. I got a 1570 on my SAT with a perfect math section, and ever since then I've been helping as many students as possible get a 1500 or a top 1% SAT score. So if you enjoyed this video and you're looking for more support with your SAT, go ahead and check out the description of this video. I'll have a link where you can get free help with my SAT masterclass. But aside from that, let's just jump into the video. So first off, we're going to look at intercepts and solutions, never do algebra again. So we're actually just going to jump into Desmos for this one. And the first thing that you need to know is, if you've never seen Desmos before, basically just how it works in a nutshell is that you can put in any equation on the left here, and if it's something that can be graphed, it'll be graphed over on the right here. So you can just put in something like 5 plus 5 or 5 plus 4 equals, and you'll just get a number as if it's just a regular calculator. But if you put in something like y equals x, you can see that it will actually graph this line on the graph to the right over here. So you can basically do a ton of things with Desmos. So the first thing we're going to look at is intercepts, and how this works is you can put in any function that you want and you can hover over any intersection point and it will automatically give you that point. So for example, say that we just put in x equals y. If you hover over the center here, you can see that an intersection point between the x-axis, the y-axis, and the line is 0, 0. And if we put in something like x equals 5y, like plus 5 or something, then we can see that we'll actually get two intersection points. This is the y-intercept, so 0, -1, and you'll also get the x1, 5, 0. Now, another thing that you can do is say that you have two lines. So say we had x equals 5y plus 5. Actually, that's a really weird way to write a line. Let me do like a more regular way, like y equals 5x plus 2. And then let's say that we have another line, such as y equals -2x minus 4. Then you can see that these two lines will have one intersection point, and now you can also hover over that point and get the exact point, or at least to like 5 decimals or whatever. And then you'll still also get all of the x and y intercepts of both of the lines, which is really cool. You basically, like, if you want the x and y for this first line, you have to click on the equation up here, and then you can get it up here and right there. But if you want it for the blue line, you click on this one, and now you can get it for the blue line. Another really cool thing is that you can also put in, like, say we had y equals 2x squared plus 3, then you can also get the intersection points for two functions that aren't just two lines. So that's another really cool thing. So let's look at a problem where you could actually use this function to get the answer relatively quickly. So it says, if x comma y is a solution to the system of equations above, which of the following could be a value of x? So we have y equals x plus 1 and y equals x squared plus x. So we can actually go and just plug these two equations in. So it was y equals x plus 1 and y equals x squared plus x. And by the way, how you do the squared is basically when you're typing out the equation, sorry, that's supposed to be equal. Essentially what you'll do is you'll do shift, and then on a Mac it would be like a 6 where it has like that little pointy thing, and basically that's just going to move your cursor up into like the exponent place. So that's how you do that. Now we have these two functions graphed, and what we're looking for is, if x comma y is a solution, what could be a value of x? So we can see that there are two solutions for these two functions, and that's going to be right here and right here. Now, the cool thing is that we can immediately see that the x value either has to be -1 or 1, and so when we look at the answers, only one of these is going to be -1 or 1, and so we know that the answer is A without actually having to plug in any sort of like solving for anything, solving for x, whatever. So it's really cool because we didn't actually have to do any math. We just plugged in these two functions and immediately got the answer from these two graphs. So that's how you can use intercepts and solutions, never have to do algebra again. The next thing we're going to look at is tables, get equations for functions in seconds. And in case you didn't know, this is another really cool thing about Desmos, is if you go to this little plus up here on the left, you can click on table, and then you can actually input tables. And so let's just take a quick look at some examples. Let's say that we had a few points, 5, 4, and 1, -2, or something like that. We can see the 2 points get graphed over here, and what we can actually do with these points is we can find a line of best fit through them. So we can write y, and this is, pay attention because this is a little bit weird how this one is. You're going to do y, and then you're going to hit shift -1, and that's basically pulling like the y1 values. And then you're not going to do equals, you're going to do shift, and then for me it's in the top left on a Mac, but it's like this little squiggly line. And then you're going to do m, and then x, shift -1, so for the x1 values, and then you're just going to do plus b. And this is, you can see it kind of looks like y equals mx plus b, but you're just pulling the y1 and the x1 values, and then it's going to give you an m and a b, or a slope and a y-intercept. And so we can see that it graphed a line that went exactly between these 2 points. And so it's pretty cool because you can just get a line based on 2 points immediately. What you can also do is, even if it's like a line of best fit or something, let's say that we also had the point 3, 4, you can see that these 3 points are not in a perfect line, but it will still find the line of best fit for us, which is really cool. Another thing is that if you have 3 points, instead of doing y equals mx plus b, you can also do y equals ax1 squared plus bx, and then remember you're always doing x1, so not just x, that will give you a weird result, and then plus c, and you can see that it will always find a quadratic that goes through those 3 points that we had in the table. And the cool thing is that you can change these values to whatever you want. It could be 40, and this 1 could actually be a 12, and this 4 could actually be a 43, and well, it got really big here, but you can see that it will always find a quadratic through these 3 points. And you can follow this formula just with any other equation that you know. It doesn't just have to be linear or quadratic. You can do this with any function that you want. So that's a really cool feature of the Desmos graph. So let's look at a problem where you could actually use this. So it says the table gives the coordinates of 2 points on a line in the xy plane. The y-intercept of the line is k minus 5, b, where k and b are constants. What is the value of b? Okay, so basically this is a line, and we're asked for the y-intercept of the line. So we can see there's another variable in here, right? Or I guess like a constant, but it's just going to be this k. But what you can do is you can actually use this in the table. So we can graph these points as they are, where, remember, it's the plus and then table, and then we can see the first point is k, 13. So we can literally put in k 13, and then k plus 7 and negative 15, k plus 7 and negative 15, and now you're like, oh, well, where are those points? They didn't get graphed. Well, they didn't get graphed because k is not defined yet, but we can actually have Desmos do this for us by, well, okay, so we look in the actual problem to figure out what k is. It says the y-intercept is k minus 5, b, and what you'll know about a y-intercept is that, well, a y-intercept is always on this midline, the y-axis, and at the y-axis, x always equals 0. Because you're in the middle, which means that you're not to the right or to the left at all, so you're at x equals 0. And so something interesting is that we know that k minus 5 equals 0 because it's the y-intercept, it has to be in the middle, the x-coordinate has to be 0. So if k minus 5 equals 0, k equals 5, and we can just type that down here, k equals 5. Now that we have k equals 5, it will automatically fill that in for these 2 points and graph both of them. So here are our 2 points right here. And so it automatically does that for us. We don't have to go back and plug in a 5 for all the k's. And obviously in this case, it wouldn't be too hard. You just put a 5 and a 12. But sometimes there will be a lot of like different places where the variable will be, and you don't want to go and plug it back in for everything. So it's really nice to be able to just put k equals 5, and then it will automatically put that in anywhere it needs to be put in. Okay, so this question's actually asking, what is the value of b, or the y-intercept? So one thing that we can do is that trick that I showed you earlier, where you do y1, then this squiggly line, and then mx1 plus b, and immediately we see the b value is 33. So the answer to this one is b equals 33, and you can go ahead and check it however you want. That is actually the answer, but it's really cool that you can get it that quick just using the table function in Desmos. The next thing we're going to look at is inequalities and shading to help visualize confusing word problems. So another cool thing about Desmos is that you can use the less than or equal to or greater than or equal to, whatever, those kind of symbols, and it will automatically shade your graph. So the way that you can get the less than or equal to, like you can always just type this using your keyboard, but if you want less than or equal to, you just click this bottom left thing over here, and you get a lot of the like common things that you would want to type in a calculator. So we could have something like y is less than or equal to 5x plus 2, and you can see that it will automatically shade this region, which is really helpful because sometimes it can be really hard to remember, like, okay, well, if this was actually a x and this was a y, then it would be like the other side. And so it can be a little bit confusing trying to remember whether you're like shading the top or the bottom sometimes, especially if the x and the y are kind of flip-flopped. And so this is just a very easy way to always keep that stuff straight in your head. Another cool thing is that you can graph multiple of these inequalities, and it will show you the overlapping shaded regions. So let's say that we had this line, and then we also had some quadratic, like a quadratic inequality. Let's say that it was like y is greater than or equal to 6x squared plus 4x. Then we could see that this region where they overlap and they're both shaded, that is the region where basically like these two functions would share like solution sets or something, would be this shaded region. And so sometimes you'll get a problem where it asks for a point that would satisfy both of these, and you could just graph all of those points down here. By the way, you can just put in points like 1, 2, and it'll graph the point. And so we could see that this one would satisfy this red equation, or this first one, but it wouldn't satisfy the second one. And so we could just go through the answers and plug in stuff until we got one that's like negative 0.25, 0, and we could see that that's inside of both of them, so it would be a solution. So it's really cool. You can just automatically see this without having to do any math at all. So that is how you could graph inequalities. I didn't really have a specific problem for this one. This is just like applicable to basically any inequality problem as long as you can graph it and then use it to find solutions. So there's no problem for this one. But then number 4, plugging in answers, skip entire questions. So this one I kind of just have to show you. But basically you can use Desmos to just plug in problems and basically like work backwards through the problem so that you basically just plug in the answer, and then if it doesn't work with the original information that you're given, then you know that that answer is wrong. And that way you never have to go from what they give you to an answer. You just plug in the answers they give you and work your way back and check if it works with the question. So for example, for this one, it says, which of the following is equivalent to the expression x to the 4th minus x squared minus 6? And then we have A, B, C, and D for different solutions that should be like equivalent to this. So what we can actually do is just go ahead and graph this first thing in the question. So that's going to be x to the 4th minus x squared minus 6, I believe. Yes. And so we have this kind of funky looking function right here. And all that we have to do is go ahead and, if we didn't know how to factor this, we can just plug in all of these and see if it's the same function. So for A, it's x squared plus 1, x squared minus 6. So we can plug that in, x squared plus 1, and then x squared minus 6. So we can see that it's a pretty similar shape, but it's not directly overlapping. So this is not going to be the answer. And we can go ahead and just do this for all of the other answers until we get to the right one. So B is x squared plus 2, x squared minus 3. So it's plus 2 minus 3. And we can see, boom, that one, it didn't like disappear, it didn't go anywhere else. It just overlaps exactly. So this is going to be the answer. And you can see that it's overlapping because like if you change 3 to 3.1, you can see that it's off a little bit. So when it's just 3, it's directly overlapping. So that's really cool that we can just get the answer without having to do any factoring ourselves. We just use Desmos. It's super powerful. Okay, the last thing we're going to look at is sliders, and this is how you just don't waste any time trying to plug in for different values for variables and stuff like that. You can just do a slider, immediately slide through all the possibilities of the values for that variable, and immediately find the right one. So the problem for this one is this one. So it says, in the given system of equations, P is a constant. If the system has no solution, what is the value of P? So this one's a little bit hard to see. The question's just formatted weird, but basically there's a split right here between the y and the 1/2. So it's like two different equations, and one of them has a p in it, and basically we're saying there's no solution between these two equations. So we're trying to find the value of p that does that basically. So let's go ahead and graph this first part, the 3/2 y minus 1/4 x equals 2/3 minus 3/2 y. So if we graph that, let's clear this stuff. So it was 3/2 y. I think I accidentally put a space there. I don't want a space. Yeah, 3/2 y minus 1/4 x, so minus 1/4 x equals 2/3 minus 3/2 y equals 2/3 minus 3/2 y. So that is our first line, and we'll have to kind of go back up here to see it. So that's our first line. And then let's go ahead and graph our second line, which is 1/2 x plus 3/2. So 1/2 x plus 3/2 equals py plus 9/2. So py plus 9/2. And now you can see it automatically pops up the option to add a slider for p. And so if we go ahead and click that, it will do what it says. It will add a slider for p. And so now we have these two lines, and it automatically gives p a value of 1. But what we're looking for is for this system to have no solutions. So if a solution is where they cross, then obviously p can't equal 1 because the two lines cross right here. So what we have to do is basically mess with this p value until we get two lines that are never going to cross. And so the only way for two lines that are infinite in both directions to never cross is for them to be parallel. And so we're basically going to be looking for these two lines to be parallel. Now this looks pretty close, but we can see that if we zoom out here, eventually they do kind of widen out over here and narrow in over here. So if you zoom out, it can kind of help you make sure that it's actually parallel. And so we can see that like most of the time College Board isn't going to give you like some crazy weird number like 5.5 or 5.8 or something. It's usually going to be like a whole number, so you can just go to the whole numbers and check and be like, okay, well 7, those definitely cross like somewhere near the middle. 5, they also cross somewhere near the middle, but if we go in the middle of those, if we go to 6, then we can see that these two lines are actually perfectly parallel, and we could basically drag and follow the lines forever, and they never get any closer or any further. So that means that p equals 6, and so based off of that, we can just immediately find the answer for this. So I think that's really cool and a really powerful feature of Desmos. Now hopefully this video was helpful on introducing you to some of the ways that you can use Desmos in your SAT. But it's important to remember that Desmos is only one piece of many that's going to help you get the score you want on the math section of your SAT. So if you're looking for a more in-depth guide to the math section as a whole, go ahead and check out this video that I made, and it'll get you sorted, get you a good math score on your SAT.